Welcome to E-Pathshala lecture series in computer science. This course is on operating systems, and in today's class we will continue to learn about process synchronization, the problem of process synchronization, and we learn about some solutions to the synchronization problem. So, the objectives of today's lecture is to know different solutions to the critical section problem and to understand how the solutions satisfy the conditions of mutual exclusion, progress and bounded waiting. So, we have learned earlier that cooperating processes share data. So, when there is more than one process in the system which needs to share data among them, they are called cooperating processes. And these cooperating processes, they share data using some common variables or some common data structures. So, these variables and common data structures that these processes access have to be synchronized properly. If synchronization is not done properly, then the process may try to overwrite the variables or the data may result in inconsistencies. So, we have defined in the last class about this critical section problem. So, what is this critical section problem? There will be some portion of code in each of the processes which is said to be a critical section of code for that process, and this critical section of code for that process should be executed atomically. Only if it is executed atomically, then it will not result in synchronization problems. So, there are a number of solutions to this critical section problem. In the last class, we learnt about solutions to this critical section problem, and the critical section problem, we saw that the solution to the critical section problem makes use of a single variable called turn, and using that turn, it tries to provide a solution. And now we will continue in this class to learn about more other solutions to this critical section problem. The algorithm that we saw in the last module used a single variable, and that solved the condition only for mutual exclusion. The other conditions of progress was not being satisfied by the solution that we saw earlier. And this progress was not satisfied because in the algorithm there was a strict alternation between two processes. That is, if process P0 enters critical section, then process P1 has to enter critical section, and so on. So, P10, then P1 and then P0 and P1, only in that manner process can enter critical section. And for this they try to come up with another solution that we will see today. And in this solution, there is a flag variable for each process. So, flag is an array where there are two elements, flag of 0 and flag of 1, and each of these values is initialized to false. And when a process is ready to enter critical section, it will make the value of flag to be true. Now, this is the algorithm that each of the process will execute. So, look at this algorithm. This portion, that is red and blue, is the entry section, and then you have the critical section, and after coming out of critical section there is a portion of code that the process will execute, which is the exit section, and then you have the remainder section. So, this process Pi which needs to enter critical section will first execute this entry section, and after coming out of critical section it will execute this exit section. So, what does it do in the entry section? As I told you, you have a flag variable for each process, and now consider there are two processes P0 and P1. Say P0 will execute this part before it enters critical section. Very similarly, P1 will also execute this part before it enters critical section. So, if P0 executes this part of code, for P0 it will be, the code will be something like flag of 0 equal to true while flag of 1, then critical section, after coming out of critical section flag of 0 equal to false, and then remainder section. And if P1 is executing, then for P1 the code will be like flag of 1 is equal to true, while flag of 0, critical section, flag of 1 equal to false, remainder section. So, now there are two processes and this is a solution for two processes to solve this critical section problem. And if what actually happens here is, say first the process that tries to enter critical section makes its flag to true and then checks if the other processes flag is true or not. If this flag of j is true, while true, as long as this is true, it goes on in this while loop. It cannot come out of the while loop as long as this condition is true. So, that is when as long as the other process's flag is true, this process will keep on waiting. We will now see how this works and how this satisfies the mutual exclusion condition. Now, look at this example. You have processes P0 and P1 who are trying to execute this algorithm, and each process has got its own variable called flag, flag of 0 and flag of 1, and both are initialized to false. This is the initial condition. And now P0 wants to enter critical section and it sets its flag, that is flag of 0, to true. Then it checks if the other process's flag, that is if P1's flag is true or not, that is the while flag of j condition. It finds that flag of j, that is flag of 1 here, is false. So, since flag of 1 is false, while of false will be executed, and because the condition within the while loop is false, it comes out of that while loop and process P0 enters critical section. And when P0 comes, or when P0 is currently in the critical section, say, and say now P1 wants to enter critical section. So, P1 executes its entry section of code. So, P1 executes flag of 1 is equal to true and it will check if flag of 0 is equal to true or false. So, here flag of 0 is equal to true, that is the other process's flag is true. So, while of true will be true and P1 continues to execute the while loop or continues to be in the while loop and it will wait here in the entry section. And say now P0 comes out of critical section. When P0 comes out of critical section, then the code, according to the code, in the exit section, it makes flag of 0 to false. So, it changes flag to false. Flag of 0 is changed to false. What will happen to P1? P1 is currently in the while loop. It is continuously checking if flag of 0 is becoming true or false or whatever. So, that is while flag of j semicolon. So, P1 is continuously checking if flag of 0 is true or false. So, as long as the flag was true, it was waiting, and now flag of 0 has become false. So, while of false makes P1 to come out of the while loop and P1 enters critical section. So, now here we see that when one process is in the critical section, say when P0 is in the critical section, its flag is set to be true and the other process will not enter its critical section because the other process will check this process's flag, and as long as this process's flag is true, this process will keep on waiting and hence mutual exclusion is satisfied in this algorithm. Now, we will move on to see if this algorithm satisfies progress, that is the second condition. So, what is progress? When two processes try to enter critical section at the same time, the one process should not be one process should not be made to wait continuously or indefinitely. There should be a chance for both the processes to enter critical section. So, that is progress, or both the processes after wanting to enter critical section should be able to progress. and we will see how this is satisfied in this algorithm, or we will see if this algorithm is satisfying this or not. So, you have again two processes P0 and P1, and you have flag of 0 and flag of 1, both are initially set to false. And now both the processes assume they want to enter critical section. So, first say P0 gets the CPU and it sets flag of 0 equal to true, and immediately say there is a context switch and P1 takes the CPU, P1 also gets a CPU, and when P1 gets a CPU, P1 also wants to enter critical section, P1 is in the entry section, so P1 also sets flag of 1 to true. Now what happens? Both the processes, say P1 when if it tries to check while flag of 0, it will find flag of 0 to true and it will keep on waiting in its while loop. Say because it is waiting, say CPU is given to P0 and P0 will also keep on checking flag of 1, it will find flag of 1 to be true and P0 will also keep on checking or keep on going in the while loop. Now we find that process P0 and process P1, both of them they are continuously checking flag of 0 and flag of 1 and they find them to be true and both of them do not enter critical section. And this goes on indefinitely. Both the processes cannot enter critical section, they are in the entry section indefinitely. So, our condition progress is not satisfied. So, this algorithm, though it satisfies mutual exclusion, it does not satisfy progress. So, it cannot be told as a proper solution to the critical section problem. So, now they came up with another algorithm where they try to combine the features of both the algorithms, algorithm 1 and algorithm 2. So, what is done in this algorithm? We will see. In this algorithm, the code goes something like this. You have the code for process Pi given here. Here you have a variable turn as well as you have an array flag. Similar to what we had in the previous two algorithms. In the first algorithm that we saw, we had a single variable turn, and here we have, and in the second algorithm we had a flag of 0 and flag of 1, a flag array. Here we try to combine both. We try to have both turn as well as flag. And this turn is a variable that is common between P0 and P1, and flag is an array where you have flag of 0 which is used by process P0 and flag of 1 used by process P1. This again is an algorithm which gives a solution to two processes. When two processes try to compete for the critical sections, how to synchronize. Okay? And we will see what happens here in the entry section. Say this is the code for process Pi. Assume P0 is executing this code. So, P0 will execute this code and set flag of 0 to be true, and then it changes the value of variable turn equal to j, that is it changes it to 1, and then checks if flag of j and turn is equal to j. That is, what is flag of j? Flag of j is the flag value for the other process, for the next process. So, here the next process is P1. So, it checks if flag of 1 is true. When will flag of 1 be true? Flag of 1 will be true when process P1 wants to enter critical section. And if flag of 1 is true, it also checks if turn is equal to j, if turn variable is pointing or equal to 1. So, if the other process wants to enter critical section and if the value of turn is also equal to the number of the other process, then this process waits. So, as long as flag of j is true and turn is equal to j, this process Pi waits in this while loop. It continuously keeps on checking this while till at least one of these becomes false. So, here after this becomes false, this process can come out of critical section, and after coming out of critical section, it will make the value of flag to be false for the other process. So, this flag of 0 is made as false. So, if process P naught is executing this, it will make this flag of 0 equal to false and goes to the remainder section. Now, we will see how this algorithm satisfies mutual exclusion. So, we consider a scenario first. You have two processes P naught and P1, and each process P naught has got this variable flag of 0 and P1 has got this variable flag of 1. And there is this common variable turn which can be accessed and modified by both process P naught and P1. Initially, for flag of 0 the value is false, and for flag of 1 the value is false. This is the initial value that has been set. And then for turn, the initial value can be either 0 and 1 or 1. You can set it to 0. Here I just assume that it is set to 0. And now P naught wants to enter critical section. So, what does P naught do? It has got, there is a statement called flag of I is equal to true. So, it changes its flag value, flag of 0 to true. And then there is another statement, turn is equal to j. That is, it changes the value of turn, the variable turn's value to 1. And then it checks if while turn is equal to j and flag of j is equal to true. But now flag of the other process, flag of P1 is false. Okay. So, that while condition, while flag of j and turn equal to j, the first part of that flag of j being true is not true now. So, it is false. So, that while loop, the condition within the while loop becomes false. So, because the condition within the while loop becomes false, it comes out of the while loop, and next is it can enter critical section. So, P naught is now in the critical section, and this P1 is not even attempting to enter critical section. So, because P1 is not attempting to enter critical section, P naught comes out of critical section and safely in the exit section. What does it do? It changes its value of flag to false. So, flag of 0 is made to false and P naught goes to the remainder section. And now, we will look at a scenario where we will see how mutual exclusion is satisfied in a scenario where both the processes are trying to enter critical section. So, here again process P naught and process P1, you have flag of 0 and flag of 1 for process P naught and P1 respectively, and there is a variable turn which is a common variable and it is initialized to 0. And these values of flag of 0 and flag of 1 are also initialized to false as we saw in the earlier case. Now, P naught wants to enter critical section. So, P naught changes flag of 0 to true, and then it changes turn is equal to 1, and say there is a context switch now, and P1 also wants to enter critical section. So, what does P1 do? P1 will set its flag of 1 to true, and then P1 will change the value of turn equal to 0. Now, there are two processes P naught and P1, both are competing to enter critical section. So, who will now enter critical section? See, if P naught for the next statement that is being executed, say if P naught tries to execute while flag of j and turn equal to j. Flag of j is true. What is flag of j? Flag of j is flag of 1. For P naught, flag of j is flag of 1. So, it finds that P naught finds that the flag of the other process is true. So, the first part in that while condition is true. The second part is checking if turn is equal to the other process turn, but turn here is now equal to 0. So, turn is not equal to the other process turn. So, that while loop becomes false, the condition within the while loop becomes false for P naught, and P naught can enter critical section. And while P naught is in the critical section, say if P1 tries to execute the next while loop. So, P1 changed flag to true, it changed the value of turn equal to 0 and it wants to enter critical section. Before that, it checks if flag of the other process is true, it is true, and it also checks the value of turn if turn is equal to the other process turn. It finds that the flag of the other process is true and the turn value is also equal to 0, that is equal to the turn of the other process. So, P1 does not enter critical section, it waits in the while loop. So, P1 continues to be in the while loop, waits to enter critical section. So, here we see that when one process P0 is in the critical section, the other process P1 is not allowed to enter critical section, it waits and mutual exclusion is satisfied. When P0 comes out of critical section, what happens? It changes its value flag of 0 to false. So, when flag of 0 is changed to false, now this P1 is keeping on checking that while loop, while flag of j and turn is equal to j. Now, flag of j for P1 is flag of 0 becomes false and hence that becomes false and that while condition becomes false and P1 can enter critical section. So, once process P0 comes out of critical section, P1 is allowed to enter critical section. So, here you see that whoever has changed the value of turn finally and that particular corresponding to that particular number process enters critical section. So, here we see that this algorithm satisfies mutual exclusion. We will now see if this algorithm satisfies the next condition, that is progress. So, you have process P0 and process P1, you have flag of 0, flag of 1 both initialized to false. Turn value can be either 0 or 1, let it be 0. Now, P0 say wants to enter critical section. So, it changes its value of flag, it changes flag of 0 to true. And then P1 also wants to enter critical section, P1 changes the value of flag to true. Both of them are in the entry section, they try to enter critical section. Now, who will enter critical section? That depends on who finally changes the value of turn. Say if P0 changes the turn first in this case and it changes the value of turn to 1 and then P1 changes the value of turn, it changes the value of turn to 0. So, now who should enter critical section? The value of turn is equal to 0, the value of flag of 0 is equal to true, the value of flag of 1 is also equal to true. So, when P0 checks the value of turn, it will find that the value of turn is not equal to the turn of the other process and this is equal to true. So, the condition fails for P0 and the while condition is false for P0 and P0 enters critical section. And then it comes out of critical section, makes equal to false and then P1 can continue. So, you can now find the difference or see the difference between this process, this algorithm and the earlier algorithm that we saw. In algorithm 2, we saw that when both the processes P0 and P1 set the value of flag is equal to true, they go into an indefinite waiting. Both of them are not able to enter critical section in algorithm 2. But now here, even though P0 and P1 set the value of flag to be true, depending on the value of turn, they are able to enter critical section. So, turn can either be 0 or 1, it cannot have two values and depending on what value turn has, the corresponding process enters critical section. So, progress is satisfied, no process waits indefinitely to enter critical section. And look at the scenario again for progress. Initial values of flag and turn, P0 sets flag to be true and P1 also changes flag to be true. So, here I see that P1 changes the value of turn first. So, turn is kept as 0 because it has that code turn equal to j. So, for P1 j will be 0, so turn is made as 0 and next P0 executes, it changes the value of turn to 1 and now here you see that because this was changed last, because P0 changed last and it changed the value of turn to 1, P1 enters critical section. So, P1 is the one who enters critical section first. So, as I told you, depending on the value of turn, the process, one of the two processes P0 or P1 enters critical section. and after coming out of critical section it will change its value of flag to false and the other process can enter critical section. So, we have seen that progress is also satisfied in this algorithm. So, both mutual exclusion and progress are satisfied. And how about bounded waiting? What is bounded waiting? Say there are two processes that are waiting to enter critical section and both have requested to enter critical section. So, say after a particular process has requested to enter critical section, the amount of time that process has to wait should be bounded or limited. We will see how this algorithm satisfies this bounded waiting. Say look at this scenario where you have process P0 and process P1 and flag set to false initially, initial value of turn is 0 and P0 is first trying to enter critical section, it changes its value of flag to true, flag of 0 is set to true and say process P1 also wants to enter critical section, it changes its value of flag, that is flag of 1 is set to true and this changes turn to 0 and this changes turn to 1. So, who will enter critical section? Automatically P1 will enter critical section. Say if P1 comes out of critical section, it enters critical section and after coming out of critical section makes the value of flag to false. Now, say P1 continues to use a CPU, there is no context switch and P1 wants to enter critical section the second time. So, P1 changes flag of 1 to true and it tries to enter critical section. And what does it do? It tries to change the value of turn equal to 0. Now, here you find that P1 cannot enter critical section because it changes the value of turn equal to 0. Unless this process is entering critical section, this process cannot enter critical section because the other process flag is already true and the turn has been changed true by this process now. So, unless P0 is entering critical section, P1 cannot enter critical section. So, here you find that if this process P0 was not in the entry section, if it had not changed the value of flag to true, then this process, even though it changes the value of turn to 0, this process can enter critical section. Progress will be there. But here, because this process had wanted to enter critical section, it had set the value of flag to true earlier, and even though this process wants to enter critical section the second time, this is not allowed unless process P0 is allowed to enter critical section. So, here we see that bounded waiting is satisfied, that is after P0 had requested to enter critical section, the number of times P1 is allowed to enter critical section is limited. In this case, after P0 had requested to enter critical section, P1 is allowed to enter critical section only once, not more than that. Okay. This algorithm provides a solution only when there are two processes. When there are more number of processes, this does not provide a solution. So, what we learnt in today's class? We learnt about solutions to the critical section problem. We saw two algorithms and we saw if they satisfy the mutual exclusion, progress and bounded waiting. But this is a solution only to two processes. When there are many processes, this does not provide a solution. So, the references is this. Thank you.